Okay. Good afternoon, everybody. For those who don't know me, I'm Luc. For those who do know me, I'm sorry. Probably most of you don't know me because it's the first time I come here. I thought, why not give a presentation then? It's a matter of introduction. The presentation I'm giving is about my experience using Blender while starting up my own small software company, actually at the beginning of this year. And being kind of a Blender junkie, try to use it as much as possible with relation to this. Maybe first a bit of a background on myself and how I got to found this company. I'm quite new to Blender, but I have quite a bit of experience in industrial 3D measurement techniques. And what kind of techniques I'm talking about, it's mainly optical measurements. I'll show it later on with the 3 linear CCDs that's tracking infrared diodes. Probably quite a few of you know systems like Vicon or Qualisys for motion tracking. This is quite similar, but then applied for industrial measurements. Which kind of applications do we use it for? For my personal professional background, structural testing and motion analysis, we'll give some examples on it. And the main profession company I work for is also using it in conjunction with a laser projection scanner to digitize geometries for quality inspection or for reverse engineering. Kind of tracker I'm talking about is it's like a beam with 3 linear CCD cameras. Most of other systems will work with 2 square CCD cameras. Advantage of using linear CCDs is that the real-time capabilities become much better. Also because you have the camera here with 3 linear CCDs, kind of controller, and then this is representing the infrared diodes, which are fired. These are multiplexed, so you don't have something like marker switching, which you have with stereo vision square CCD systems. Kind of measurements you can do is with one LED, you have 3 degrees of freedom. Take 3 infrared diodes, put them on a rigid body, you have 6 degrees of freedom. And if you combine it with like a laser line scanner, then you can do kind of other measurements as well. Here are some pictures of systems. So typical companies actually in industrial applications are companies like Northern Digital, Nikon Metrology, Creaform, and Phoenix Technologies. So here you also see an example of such a laser line scanner. It's a black housing with infrared diodes, about 40 all built into the housing. And the neat little device inside here is projecting a laser beam on the geometry. The camera captures it, and this is then digitized. Systems like that, because for motion capturing on humans, it's being used as well, but there's big difference in A, price, B, accuracy. So systems like that will go to, well, let's say something like 1/10 of a millimeter. On industrial deformation and motion applications, which is a bit of my background in that company, we've been using these kind of measurement systems on applications like structural stiffness. And this setup that you see here is something that I actually did myself a few years back. I can give you some information on it. It's a test facility at Ruach in Switzerland. They decided to get rid of their Lockheed Starfighters and bought the F-18 from McDonnell Douglas. Now this is an air carrier kind of airplane. Obviously, Switzerland doesn't have any aircraft carriers. So they made some adaptations to the wings, like here on the structures. If you make adaptations to the airplane, you have to let's say, certify it. You have to test it for stiffness, and you don't want any cracks in the wings and stuff like that. So they start up a test program then, where at one side they have virtual simulation using FE, trying to get a prediction out of when will cracks appear, but don't trust simulation, do some real-life testing as well, and that's what you see here. So you have an actual F-18 full scale, and underneath you can see all these yellow push rods, which bend the plane following two specific, let's say, flight configurations. So after 5,000 flying hours simulated, they compared simulation with real-life testing and saw cracks which were not expected. So within 1 week of time, they needed to check out is it the stiffness of the actual plane which is bad or the parameters inside the FE model. So we did this kind of measurements using 4 of these trackers, putting them in the air, putting the whole plane full with LEDs. And we did the measurement job in 1 week, actually, getting all the deformations out. Another application is motion measurements on parts. A simple example here. Automotive industry, closures like cabrio roofs, doors, trunks, stuff like that. They want to evaluate if you close them, how much, for example, overshoot there is. But they can also use it with a laser scanner to check stuff like flush and gap on the body joints. Now the last one I show here is an important one. It's called ship model stability testing, where you put some LEDs on the ship model. You let the ship model go in a towing tank. You produce some waves simulating rough conditions like a 7-year storm or 10-year storm. And then you see how your actual ship, based on the model testing, is going to behave in bad weather. This is something that I was doing 10 years ago, but then the company was taken over by another company, and one of the first things said, this is much too small actually as an application. We're not interested in it. We're not going to do it anymore. So I thought, okay, so maybe if you don't want it, then I take it. A little bit on towing tanks here, you have, they go up to 600 meters of length. It's quite amazing. If you're standing at one side and you look at the other side, you don't see it anymore. It's, it's far away. The ship models themselves are also quite big. They go up to 6 meters, all equipped, of course, with a wave maker. And very important in these applications that you have 6DoF motion registration, because that's the final or the important thing about doing this kind of simulation. If you do these measurements, it has to be, of course, real time, because you want to merge actually measurement signals with a lot of other signals, like wave lengths and stuff like that. And you also want to control the position of this carriage. It has to track the ship models in real time. Carriage can move in the X of the carriage, but can also move in the Y, for example. So when my big company said, we don't want this application anymore, like I said I'll take it. And I started talking to one of the contacts I had in the past, actually, with these towing tanks. And one of the big players is actually here in Holland, in Wageningen. It's called Maren. And they like the idea of continuing the software support for them. So that happened 3 years ago. And this year I started the company and started approaching also the other towing tanks that I know, like in Europe, but also intend to go to Asia and America in the following years. Important about the application is that I wrote it. It's very specifically tailored towards towing tanks. You have like 150 towing tanks. It's not a big market, but if you're like a small niche company, you can make a buck out of it. The software, actually, I also like to extend in the future back to structural testing. Now, how does Blender come into play here? Like I said, I wanted to use it wherever I could, and with the, let's say, the experienced newbie background that I had in Blender, one of the things where I use it was in the software to produce my own icons. It's important to give a good first impression of the user interface. I also use it for illustrations in the manual, and further on also for mechanical prototyping. I think it's quite good for that as well, because you make very nice photorealistic renderings of it. Then marketing-wise, it's not just writing software, you have to get it to the customer as well. Stuff like the logo development, well, the background of the computer that you saw is, of course, in Blender made. Brochure development, where you want to have some nice icons as well, and product movies. And then a third thing where you can use Blender is in, let's say, feasibility studies. You go to a new customer and he says, can you do this, this, this? Then first thing you have to do is actually, how many cameras do I need, for example? What is the measurement volume? Is everything visible? Also there actually Blender can be used, of course. Yeah, here a bit on the icons, the very first version of the software. You start Googling for icons and you take a little bit here, a little bit there, and after a while you get something like, it's a bit of a mess. Because the viewing angles are different, the color schemes are different. So you think you have a nice icon, but it really isn't. And in some cases you also need very specific items, what you don't find on the web anyway. So a better approach there is actually in Blender. Make a kind of standard tree light studio. You just place into it whatever you want. And with the same color set. So the icons here actually the bottom are all made with Blender. Making the icons is quite simple, of course. You render it to RGBA PNGs, which can be used directly in the software, or like with Axelialis Icon Workshop, you can still convert them to icons. And important is that the icons are more consistent, giving a more consistent user interface impression. And actually it's much quicker working like this than doing research or doing, like, I don't know, in a bitmap program, trying to paint something decent. And third advantage of using your own icons is that you can reuse them, of course, in the manual. I don't like the color stuff in the manuals, so I used a combination of the edge in the rendering of Blender together with the freestyle in 2.49 to produce stuff like this. Just black-white, so if you print it, still looks nice. And all the icons that I made, same treatment, convert them with the edge and the freestyle to stuff like that, and put it in the manual. Product development, prototype design. What you see here is an example in the past of a multi-directional probe, where you have small infrared diodes incorporated in a configuration so that you can go around it and you always see 3 LEDs. So you can make a 360-degree turn and you will always be visible. At this moment, I'm not really busy developing stuff like this, but in the future, I may anticipate to that when touring tanks start to ask, can you also make special probes, basically, that go with your software. So there actually, certainly use Blender then to make first designs and have a look at it. Feasibility studies, also Blender's very nice there, because here you see this optical tracker. And what you see here is the measurement volume. It goes from, let's say, 2 meters up to 6 meters, and gives you like 17 cube meters of measurement volume. It's like a mid-size family car. Now, if you have something that you need to measure, and the customer wants to know, can I do it with one camera? Do I need more trackers? And you get a CAD file, typically IGES format, converted to like wavefront import, and then you can nicely see where do I need to put my camera, and how much measurement space do I have left over if I put my big object into it. Once you have done that, of course, you can use this environment also, render it to a nice picture and put it in a presentation and show it to the customer. It's also a nice advantage. Here's another more extended example of that. It's a customer in China who wanted, it's a big robot arm, 2 links, a length of 5 meters. And they wanted to measure the motion of that robot link while it was moving like this. It's a movie, so looks a bit like a big watch. Not sure what they're using it for. So they wanted to measure the whole motion of this joint and the end link throughout the whole motion. With one camera it's not possible, of course. So you can start putting cameras all around. And you can follow it as the arm is going through the different measurement volumes to make sure that you can track the end effector all the time. Also, you can think further on conceptually, like you have to align all the cameras, so you have to make like alignment spheres that you have to attach to the wall. Once you've made that and you say, okay, you need 5 cameras and it will work, again, you can send the movie over to China and give a first visual impression of about how it's going to look like. Marketing-wise, of course, Blender is also very good, like logo design on the name cards everywhere where I can put it, I put it. Brochures and data sheets. Let's open it, of course, here. So I made of a kind of a live data sheet with it's a PDF, but it has animations inside, so you can send it to a customer. He can click on the animations, and he can also print it and give it to colleagues, basically. Very simple, very rudimentary, but good enough actually to explain what is doing what. Okay. One of the plans I have for next year, like I said, one of my key customers is here in Holland, biggest institute. I already asked them if next year I could take some real-life footage of the towing tanks with a professional cameraman, and then I want to merge it together with Blender simulations to get a nice product movie. Why? Because I want to go outside selling the software as well. And then, of course, you can fly over and give the presentation, or you can make a very nice product movie that makes it clear actually what everything is doing. Well, I think I have one of the shorter presentations today, so I would like to thank you for your attention. There's some time for questions, I think. So.
It was really cool to see your work for Marin.
You know Marin?
Yeah, in the 90s, when I had an animation studio, we did lots of work for Marin.
Oh, really?
Yeah. So I was wondering if they mentioned, did you mention Blender to them or not?
No, not really. I'm just
focusing. But they might still have video programs with animations. I made for them even.
Oh, really?
Yeah.
If you have some names
so
there,
you should try to get that, yeah.
We work together.
Yeah.
I'm going there back next week, Tuesday, to give some training on
we'll mind them, yeah. Okay. Any questions for Luc?
Thanks. Why do you use infrared LEDs and no optical markers? Would it also be possible with optical markers?
Yeah, it does, because, well, I think the infrared is more matched to the sensitivity of the CCDs. If you would take blue markers, you would need more power actually out of the LEDs to get it working. But we made a special version of the tracker that was capable of taking measurements underneath in the water, also for Maren. You can't use infrared there because the water will absorb all the infrared. So there we removed the infrared windows in front of the CCDs, went to visible red light, and yeah, it works, of course.
Yeah, of course I have to ask, how important is the information from the CCD cameras, like the field of view? Can you, for example, instead of place multiple cameras, widen the field of view and calculate with that?
Well, the design actually of the type of trackers that we work with is such that it's like pre-calibrated. What happens is there's like a carbon beam inside, all the 3 CCDs are glued to it, and the whole thing is calibrated using a huge CMM with a huge volume. Once you have done that, you don't calibrate the position or the focal length or whatever from the cameras anymore. You leave it like it is. The only thing that you still need to do is compensate for temperature fluctuations if your measurements require traceable accuracy.
Okay.
No.
Okay. Thank you, Luc.
Okay. Thank you.
Next talk is the BioBlender. Monica, we will find out if the projector is working this time. Yeah, is it? She always had bad luck with our system here. But this time it will work, right?
We'll see.
There are some people who are into augmented reality and combining actual footage with simulated footage. Always like to have an ear for that. Plenty.
Dankjewel.
Zou je weekend gebeuren? maken?
Ja?
Ja?
We hebben daar 2 weken best grote bus voor gedaan.
Ah, dat was in de jaren 90 dan nog.
Simulaties of visualisaties van...
If I see here, I don't see here. So it's going to start Ubuntu again. Vero? And now it's not starting at all. That's great. Facciamolo ripartire. You're not going to use the... Okay, okay. Let's start it again. Ma però poi dopo... Vediamo se posso. I think we shall start by showing you the movie we made, and then some details about how we made it and what you see. So let's start off with the movie. It's not moving. Okay. So. Non funziona un cazzo di niente, come al solito. Try again. You have it going?
Yeah, can we switch to the other display?
No, non è sincronizzato. Prima andava.
Oh, yeah, cosa ti devo dire? Prima andava.
Qui c'è veramente...
If you can switch to the other computer, maybe we have a better luck.
Oh, I was trying to get them to switch to the other display, to this one. It's hooked up, right? I don't see it. To switch to this laptop? I was under the impression this is also plugged into
Hello up there, technology. Are you there? De balie jongens, waar zijn jullie? Tling. They are walking around here.
Well, I suggest that until we wait for we can watch the movie afterwards and we can start introducing what we are going to see. Beh, ma nemmeno in PDF. Ah, ok. So, well, the talk tonight is going to be part by myself. I'm Monica Zoppè. I'm from the National Research Council in Pisa in Italy, and part from Mike that has been working with us for some time in the development of BioBlender. That means the direct Blender interface for handling all of the functions that we use to visualize and animate molecules, which is our biological interest. Well, what we do is actually movies of